lecture based on electric drive. So we see the introduction to electric drives and its classification, its component or its features. The first electrical drives. Drives are systems employed for motion control, speed control, direction control. For that require prime movers. Drives that employ electric motor as prime movers are known as electric drives. Electric drives is about 50% of total electrical energy used for drives. So the huge amount of this topic. So most of electrical energy utilized in electrical drives. So be careful for their losses, their features, their applications, everything can be either used for fixed speed or variable speed. The most 70 out of that 75 percentage is constant speed and 25% is variable speed. So the variable speed and constant speed there have different type of their applications. So example of variable speed drive applications, constant speed and variable speed. In this supplied and constant speed directly supplied given to motor and motor to pump and valve. So whatever power we give in and power output, there is a huge amount of power loss mainly in valve. But in variable speed drive, supply is given to the power electronic circuit, then to motor and to pump. So whatever power is given, maximum power output can be achieved and power loss will be very less as compared to constant speed. In this, the phenomena of conventional electric drives for variable speed, it is mainly from so many years we are using. AC supply is given to AC motor. So the AC motor shaft is rotated and rotated shaft at a fixed speed will given to DC generator, and DC generator generate the DC power and DC power to the circuit. So we can get variable DC and variable DC given to the DC motor, and we achieve the variable speed for the load. But this system we require AC motor, DC generator, DC motor. From DC generator to DC motor, some circuit are required for variable DC. So it is very bulky, inefficient, inflexible, and for that we have to switch into modern electric drives. So next topic is our modern electric drive with power electronics converter. So here our application of power electronics is, so we can achieve the variable speed easily. The source is directly given to power processor, or we can say power electronics converters. So variable power supply is directly given to the motor, and there is no requirement of motor and generator set in this if we use the power electronics converters. So feedback is provided between power processor or power electronics converter and motors. So feedback is given to the control unit, and control unit can take decision if we whatever we have to change. This change is given to directly the power electronics converter. So this is the phenomena. In that, source directly applied to power electronics converter, then feedback and feedback control. After controlling the power electronics converter, its supply given to motor, and the variable speed is given to the load. So it's not very bulky in this, easily efficient, flexible and small. The amount is also small, and the component as compared to conventional electrical drive to the modern electric drive is very less. So it is useful for we can easily control the speed of motor. So next topic is modern electrical drives. We will further discuss what is the modern electrical drives, how it works. The power source, utility interface, renewable energy is given to power processor or power electronics converter. Then feedback is control unit, the non-linear control, real-time control, DSP digital signal processing application of um, for power electronic circuits, speed sensors, power electronics converter. They are used for controlling and feedback. And in the last machine design, speed sensor, machine theory, they are used for a three part: a power source, control unit, and feedback, and the load. The interdisciplinary several research area and expanding. This is the topic from modern electrical drives. We again the further discuss in modern electrical drive in next slide. So this is the basic structure of modern electrical drives, and this is the with component we are using in control, feedback, source in this circuit. Now the some of international company, MNC company, are producing modern electrical drives. This is the single drive. We can see the size of this single drive, sensorless vector control from Hitachi. And in the next slide, multiple drives from the ABB. So this is the multi drive system from ABB in Gujarat. ABB located in Baroda. So we can also apply for project job in ABB. We can go you can go to the ABB website and apply. So this is the multi drives. Number of motors can be speed of motors can be controlled by these multi drives. Component in electrical drives: motor, DC motor, permanent magnet, wound field, AC motors, induction, synchronous, and brushless DC. And power sources: DC like battery, fuel cells, photovoltaic, in unregulated. For AC power sources, single phase AC power source, three phase power source, for phase utility, wind generator, unregulated. Power processor: to provide a regulated power supply, combination of power electronics converter, more efficient, flexible, compact, AC to DC, DC to DC, or AC to AC and DC to AC. There are four options we can get from the power processor. First, AC to AC, fixed AC frequency to the variable AC frequency, DC to DC, and DC to AC and AC to DC. So these are, we can use any of them for controlling. Control unit: complexity depends on performance requirement, analog, noisy, inflexible, ideally has infinite bandwidth. Digital, immune to noise, configurable, bandwidth is smaller than the analog controllers. DSP or microprocessor, we can use it, digital signal processing microprocessor. Flexible, lower bandwidth, DSPs perform faster operation than microprocessor. Multiplication in single cycle can perform complex estimation. So this is, we can use the number of options for controlling unit. Nowadays they are using DSP, processor, digital, so many things for variable frequency, variable speed drive of motor. So this is the overview of AC and DC drives. AC versus DC electrical drives market by Dynamics. Before 1990s is 60% out of total drive, 60% is AC drives and 40% is DC drive. In 1995, after 5 years, the 70% is AC drive and 30% is DC drive. In 2000, 75% is AC drive and 25% is DC drives. In 2005, now change, what the change is, 60 to directly 80% is AC drive and the 20% is DC drive. So many applications of AC drives in this electrical drives. This is the impact of AC drives to DC drive in all over the drives. Overview of AC and DC drive. DC motors, regular maintenance, heavy, expensive, speed limit, easy control, decouple control of torque and flux. For AC motor, the main advantage is less maintenance, uh, weight is very light, less expensive, high speed, coupling between torque and flux, variable spatial angle between rotor and stator flux. This is the main reason why the AC motor is very useful in many applications over the DC motor. Overview of AC and DC drives. Before semiconductor device were introduced and before 1950s, AC motor for fixed speed application, DC motor for variable speed application. After introducing of semiconductor device were introduced in after 1950s, variable frequency source available, AC motors in variable speed application. High performance application dominated by DC motor, traction elevator, servo. After vector control drive were introduced in 1980s, the AC motor used in high performance application like traction, servo. AC motor favorable than DC motor. However, control is complex and hence expensive. Cost of microprocessor semiconductor decreasing. The classification of induction motor drives. For variable frequency control, there is the two type control, scalar based control and vector based control. We will further discuss in the next lecture. So thank you so much.